today we're going to talk about solving some equations that involve radicals. Overall, this isn't a terribly difficult topic. There's a couple different examples we need to talk about. So let's start talking about probably one of the most basic, pretty simple one right here. We have 4x root 2 minus 3 equals 0. So we're, at least at first, we're just going to solve the way you would think. We're just going to add 3. Now sometimes you'll see this. You'll see 4x root 2, and what you need to understand is that that's the same thing as 4 root 2x. Sometimes it's written like this though, because what will happen is when people write it like this, sometimes people get a little sloppy and they carry that radical sign over the top when it's not meant to be like that. So to avoid that problem, sometimes people will write it like this. And so the next step then is to just divide. Remember, all this right here means multiply. So I'm just going to divide by 4 root 2. So cancel, cancel. X equals 3 over 4 root 2. Now, we know that that's not proper. You can't have this radical down on the bottom, so I'm going to rationalize it. So I'm going to multiply by root 2 over root 2. And I'll get 3 root 2 over 4 times root 2 times root 2 is root 4. But obviously, root 4, you can square root that, and that's 2, and 2 times 4 is 8, so we end up with 3 root 2 over 8. And there you go. Nothing terribly difficult about that, just maybe a little bit of rationalizing down here. Now let's move on to another type that you'll see occasionally. You notice here on this one, we have 5x minus x root 3 equals 10. You have multiple x's here. So a good strategy when you have multiple x's and they're outside the radical like this is I would just factor out an x. Okay, so we're obviously trying to solve for x. So what I'm going to do is, since this is in parentheses, this is joined together. And so I'm going to actually divide by 5 minus root 3 on both sides. And so what happens is this whole thing cancels with this. You get x equals 10 over 5 minus root 3. And again, we have this radical down here, which you can't get rid of it. And so what we're going to do to get rid of that radical is we're going to multiply by the conjugate. Remember, the conjugate is basically the same thing, but with the opposite operation. So get x equals on top, I get 50 plus 10 root 3. On the bottom, if you FOIL all this, you end up with 25 minus 3. And I promise it works out like that. If you need to, go through and FOIL it all out, but it ends up being 25 minus 3, which is 50 plus 10 root 3 over 22. Now that looks great, but the problem is that's not done. We can actually reduce. Okay? And so if you notice up on top, I could actually factor out, and I'm going to actually factor out a 10. So you get 5 plus root 3 over 22, and I can reduce. Looks like 2 will go into both of these. Goes in 5 times, that 11 times. And so my final result, if I multiply this back in, is 25 plus 5 root 3 all over 11. And there you go. So again, that first step here is, since both these x's are not in the radical, we can actually factor that out. And then once I get to here, there's just a lot of conjugate work and reducing. Alright, so let's move on. Let's talk about a different type of problem that you could come across. Notice here, this time, the variable is inside the radical. So when you have a variable inside the radical, what we're going to try and do is we're going to isolate the radical. So we're going to add this 4 to the other side. So if I add it to the other side, I get this. And what's handy about that is now I can eliminate that radical by squaring both sides. So when I do that, you end up getting x plus 7 equals 4, which are probably not 4, 16. 4 squared is 16. And then that's easy enough. We can just subtract 7. X equals 9. just like that. Easy enough. Okay, sometimes they are easy like that. Okay, let's look at another one that's kind of similar. This one, you notice, this time it says cube root. Well, that's not a big deal. You just notice again that the variable's inside the radical, so we're going to isolate that radical again. So I'm going to get the cube root of 2x plus 1. If you add 5 to the other side, you end up getting 1 right there. Now over here, we squared this side because it was a square root. Squaring and square rooting are opposite operations of one another. So this time, if it's a cube root, you're going to cube both sides. So now these essentially cancel, and you get 2x plus 1 equals 1. Subtract 1, 2x equals 0. Divide by 2, x has to equal 0. Just like that. Fairly straightforward right there. And it doesn't matter what this index is. If it was a 4th root, then you would raise it to the 4th power. If it's a 5th root, raise it to the 5th power, etc., etc. Okay, last type we're going to talk about, probably the last type that you'll most likely see, is you notice here that we have two variables and they're in different radicals. Okay, so what we're going to do is we're going to split those apart. Okay, so you notice here that when we were doing these up here, we isolated the radical. Well, we're going to kind of do the same thing, except we're going to isolate one on one side and one on the other. So I'm going to subtract this over to the other side. So I'll get the square root of x plus 3 equals 4 minus x minus 2. And then what I'm going to do is I'm going to basically follow the same steps as this up here. The next step was we squared both sides. So here we're going to square both sides again. So I'm going to square this. That's an easy one. But over here, you don't square individually. Remember, you don't distribute an exponent across the subtraction sign. So what we're going to do is we're going to square this whole thing. So the left side's easy. Just x plus 3. The right side we have to FOIL. Remember, this is like saying, okay, multiplying that out. Okay, so if I do that, I get 16. Outside would be minus 4 x minus 2 minus 4 root x minus 2. And be plus, now it would be this squared. Okay, so let's simplify. We have x plus 3 equals 16 minus, combine these, you get 8 root x minus 2. Then here you get plus x minus 2. Basically, this and this cancel one another. So let's simplify a little bit more. So I get x plus 3 equals 16 and minus 2 will reduce to 14 plus x minus 8 x minus 2. Okay, so we're at this point here where we can't simplify the right side anymore. Okay, so what we're going to do is, if you can kind of just ignore this, the previous stuff, if we were just starting out like this, one of the things we would do is isolate this radical, just like we did in our problem previous. So that's what we're going to do. We're going to try and move these things to the other side and just get this radical all by itself. So if I subtract 14, so get x minus 11 equals x minus 8. I'm also going to subtract this x, get that over there too. And conveniently, these x's cancel out. So we get negative 11 equals negative 8 over, or pardon me, times square root of x minus 2. Last thing, the radical is not all by itself, so we're going to divide by negative 8. Okay, so if I move my work over here, let's just simplify a little bit. We get 11 over 8 equals the square root of x minus 2. Okay, so now, even though there's been quite a bit of work here, we are going to do what we did in a previous problem. That is, we're just going to square both sides. So if I do that, I get 121 over 64 equals x minus 2. I'll just add 2 to the other side, so it'll end up being 2 plus 121 over 64. So let's go ahead and just combine some of that. Let's see, 2 is the same thing as 128 over 64. And then if I combine that, that's 249 over 64. Does that reduce a little bit? It doesn't seem like it does. We'll just say it doesn't. I don't think so. I can't think off the top of my head if there's something that reduces it. I don't believe it does. So we'll end up right there. What's the moral of the story here? The moral of the story in all this work that we just did is that when we have more than one variable in different radicals, we split them up. Okay, that's what we did here to begin with. We just split them up. And then we squared. Now that took a little bit of effort because we had to FOIL this. So I got 16 minus 4 x square root of x minus 2 minus 4 square root of x minus 2 plus x minus 2 essentially. And I just simplified this all the way down. I kept on simplifying it all the way down. Okay, I isolated this radical again. So I subtracted the x. When I did all that, I then divided by -8. Okay, and I came up over here. Squared it. So this right here is a lot like this problem up here. I just squared both sides. Ends up being not necessarily the greatest number in the world in terms of ease, but no big deal, still works. Added 2, and I'm done. So those are all the different types of equations with radicals that you'll most likely see. Hopefully that makes sense.